I want to see what my model aeroplane sees, so here we go. First of all, I'll need to use some computer software called Eagle, which is easily the best PCB design software in the world. PCB stands for printed circuit board. You just shove things around and bingo, you've got a printed circuit board design. Next, you can print that design out twice onto acetate film. The reason you do it twice is because printers aren't that good, so they have little bits of holes and stuff in the printout. If you have two together, you're pretty much guaranteed you're going to get a solid black line whether you want one. For this project, I'm going to need a custom plastic mount, so I will use FreeCAD, which is also a fantastically awesome piece of software. With it, you can design anything at all. FreeCAD will export an STL file format, which Cura understands. Cura is also a fantastic piece of free software. If Cura understands it, a 3D printer understands it. So let's send it off to the 3D printer. Anyway, back to the PCB. There is some physical work to do, which is to chop a piece of photoresist board down to the size that you require. If you've made your own micro table saw, well, you've had a slight advantage, otherwise you'll have to use an ordinary handsaw. Ugh. The photoresist PCB is sensitive to light, so you have to remove a protective coating and then expose it to ultraviolet light. When you do that, the parts that are not exposed to ultraviolet light, i.e. the bits that you've printed on the acetate film, will remain as copper. The rest will be etched away. In this process, I will not use ferric chloride. I have used that for years, and it's horrible. It's quite horrible. This time I'm going to use vinegar, salt, and some hydrogen peroxide, which I can buy from the supermarket. Generally, this is called an acid peroxide process. You can see the copper's going green, or blue-ish. To keep the circuit board moving around, rather than using bubbling, because this is just one circuit board, I tend to just use a little game of ping pong. Just flip it from one side to the other. Next you have to sand off the photoresist, and eventually you have a very nice little circuit board. Thank you very much. First, before assembly, I'm going to start tinning some parts of the circuit board. I know you'll need a lot of solder, or at least I think I know. The surface mount components are so small, I actually need tweezers and a really heavy magnifying pair of glasses to actually see them. Ah, the 3D printer's finished. Excellent. Thank you very much. Okay, time for assembly. Hot melt glue gun. No, put the camera in the right way around. That's good. Yes, excellent. That's a good plan. The hot melt glue gun should be hot now, and it is. So, here we go. Sticking it down. Hot melt glue is possibly one of the best inventions of our entire civilization. Check the fit, see if it's going to work. Yep, and put some hot melt glue on there, on the parts that will touch the plastic that's been printed. Try and get it straight, so it's a good idea. And yeah, just wait for the hot melt glue to go a bit cold. Oops, looks like someone trapped a little wire in there, did they? Did they? Yes, I think they did. Will it work first time? What? Yeah, it works. Excellent. It works. The display, the OSD is quite, the on-screen display is quite weird, but yeah. Let's strap it to the machine. Oh, yes. Oh, yes. It works! Thanks for watching.